Make sure we're streaming. We are. All right. Okay. So we're going to be looking at, where's that at? Right here. We're going to be looking at some two-dimensional figures. Now, 2 dimensions just means you're not dealing with 3 dimensions. So it's not like sticking out. You know, it's just flat, paper-based figures. And the first thing we're going to talk about is how to classify 2-dimensional figures. So we have 3 different ways that we can classify them. And when I say 3 different ways, I mean 3 different criteria. So the first thing we're going to talk about is the number of sides. Okay? By the way, all of this that we're doing today is review for you. You have heard this before. None of this is new. Okay? I'm just refreshing your memory. So the number of sides. So let's start with, how many sides do you have to have for it to be a polygon? More than, well, you're almost right. Rethink the way you worded it. 3 or more. It has to have 3 or more. Because what's the most basic polygon there is? A triangle. So a triangle is a 3-sided shape, and it is a polygon. Now, a couple things about a polygon. All the sides have to be straight, no curves. It has to completely close, so no open spots, right? That's what makes it a polygon. What is something that's 4-sided called? Quadrilateral. Good job, Alan. So most of the time, people will say a rectangle. And a rectangle is a quadrilateral, but it's a specialized quadrilateral that has special criteria. It's not the only 4-sided shape out there, right? So everything that's 4-sided fits into quadrilateral. Okay, what about 5 sides? Pentagon. What about 6 sides? Anybody know what 6 sides is? Hexagon. Now, the next one is one people miss. What about 7 sides? Heptagon. Heptagon. Did you say that? Did you say that, Taylor? Taylor got the credit. Whoop, whoop. Hepta and septa are prefixes that mean 7. Okay. 8. Octagon. 9. Nonagon. Nonagon. What about 10? Deca. Deca. Okay, we're going to skip 11. We'll come back to it in a minute. What about 12? Dodeca. Who is this that's so on top of these? Who's that? Is that Taylor back there? It's all Fernando? Okay. Now, let's talk about 11 and then everything above 12. 11 and everything above 12, they have names. We don't use them. So we call that an 11gon. And anything above 12, we just call the number of sides gone. Okay? There are names for them. We just don't use them because they're so random and not, we don't use them. They're not utilized very often, those shapes, so we just don't bother with learning their names. Okay? So that's how you classify it based on number of sides. Now let's talk about how the sides are formed. So we have 2 different kinds of of polygons: concave and convex. Concave is where on one of the sides, at least one of the sides, it caves in. Notice how we have this little cave right in here? That's a concave polygon because one side caves in. A star, which I cannot draw. This is going to be so bad, y'all. Okay, a star. Y'all see that gorgeous star right there? That's what I thought too. It looks like Patrick. that star is a concave polygon, right? An arrow. So if you think of an arrow like this, right? That's a concave polygon because it caves in, right? Polygons that do not cave in are called convex. So like a rectangle is convex. This is convex, right? Okay. Now, there's one more way to describe or to classify polygons based on something about their sides, and that is if they are regular or irregular. Now, regular polygons, all sides, and all angles are equal. So all sides, all angles are equal. Think of regular as being the one you think of, right? If I say a pentagon, you think of, y'all, this is going to be bad. Just pretend like it looks like it's supposed to, okay? You think of this guy, right? Where all of these sides are the same. I know, Lance. And all of these angles are the same. Sure. Where all the sides are the same and all the angles are the same. Right? But this is also a pentagon. See that? That's a pentagon. But it's an irregular pentagon because the sides and the angles are not all the same. So regular, all sides and all angles are the same. Irregular, they're not. Okay? That's the difference. So when you classify a polygon, you can classify it in those three ways. So like if you look at 1.6, skills practice, number 1. And I said, classify that for me. So number 1, how many sides do we have? 4. So it's called a quadrilateral. Number 2, is it concave or convex? It's convex. Everything goes out, right? Number 3, is it regular or irregular? Irregular, because not all of the sides are the same, right? Look at number 2. How many sides? So what's it called? Triangle, right? We always think that can't be right, but that's what three-sided shapes are called, triangles. Is it convex or concave? Convex, everything goes out, right? Is it regular or irregular? It is regular. All 3 sides are the same. All 3 angles are the same. Look at number 3. Concave, is it how many sides, first of all? So it's called a pentagon. Is it convex or concave? Concave. Regular or irregular? What? Irregular. Okay. All right. So that is classifying shapes. Now let's talk about perimeter, insert, and area. Bless you. So, what is perimeter and what is area?
Perimeter is distance around.
Okay, perimeter is the distance around.
Area is the distance.
And so, area is, distance isn't quite the right word. Space. We'll use the word space. Space taken up inside. Good job, you guys. Y'all did excellent. So proud of you. Okay. Now, perimeter of any shape, with the exception of a circle, is just adding up the outside edges, right? So to find the distance around, you just add up your outside edges. Okay? Now, area is a little different. We're going to come back to area in just a minute. But before we do area, I want to talk about perimeter on a circle. So on a circle, it's not called perimeter. It's called circumference. Okay? Now, I also want to talk about area of a circle. And so I'm going to write this here. Because here's the cool thing. These two formulas for circles have the exact same numbers, symbols, and variables in them. They both have a 2, they both have a pi, and they both have an r. Now, one of them, r stands for radius, and we're going to come back to that in a second. One of them is 2 pi r. The other one is pi r squared. Now, let's talk about how we can remember which is which. Anytime you do area, it's got to be something squared because you're talking about how much it's taking, how much space it's taking up, right? So think of an area rug that's length times width. So you're squaring something. So this is pi r squared. Squared because it's area. Circumference is 2 pi r. Now what does the r stand for? Radius. And what is radius? Can we take a minute to admire that circle that's fairly decent? Y'all know how hard it is to draw a circle like that? I'm not good at it. Like you would think I would be because I draw so many of them, but I'm not at all. And that's fairly decent circle. Slightly lopsided, but not terrible, right? So what is radius? The distance from the middle to the outside edge, right? Now, if we know this whole thing, what's that called? All the way across. Starts with a D. Diameter. Diameter goes all the way across and goes through the middle. Radius is half the diameter, right? So if you know the diameter, take half of that, that's the radius. Okay? So that circumference and area of a circle, y'all have done this. I'm not going to beat a dead horse and go over and over and over this, okay? You need to learn them. You need to learn which one is which. And you need to be able to use them. But we're going to do it so much this year, you're going to be sick of it. All right? Now let's talk about area of other things. So perimeter, you just add everything up. But how do you find the area of other shapes? Well, let's start with that quadrilateral. How do you find the area of a quadrilateral? So you do, we call this length, we call this width, although it really doesn't make any difference. And you do length times width, right? Now, I want to talk about, for just a minute, the area of a triangle. Okay? So, in the past, you've probably been given this formula right here, right? Rectangle. How do I find the area of this rectangle? So, to find the area of this rectangle, I would do length times width. And by length, I mean how long it is. By width, I mean this part right here, right? So I would do length times width. Everybody agree with that?
Yes,
Okay. Now let's say I take this rectangle. Now what do I have? Two triangles that are supposed to be the same size, right? 1/2. So if I want to do the area of this triangle using what I know about the rectangle, what would I do? Divide by 2. So I'm going to take that length times width that I did with the rectangle and just divide by 2, right? Length times width is the same thing as base times height. We call them base and height in a triangle, but it really is like length and width in a rectangle. It's the same thing. And then divide by 2 is the same thing as multiply by 1/2. You get the same result if you multiply by 1/2 or divide by 2. Personally, for me, I prefer this formula for a triangle. To me, it makes more sense. Base times half divided by 2. I think that makes more sense. But I don't care how you do it. As long as you understand it, you do it. Your necklace is really. It's a good thing your name's not real long. Yeah. That'd be bad. Okay. Anything else I'm missing? Perimeter, area, circumference. All right. Let's talk about 10, 11, 12, and 13 real quick. So on 10, 11, 12, 13, we're just going to talk about like one of them. It says graph each figure with the given vertices and identify the figure. Find the perimeter and area of the figure. I'm going to give you some graph paper so you have something to graph, right? But if you look at number 10, do we have to graph that?
No.
Do we have to graph that to know what shape that's going to be?
No.
How many points you got?
3.
So how many vertices do you have?
3.
3. So how many sides do you have?
3.
3. So what shape is that? It's a triangle, right? Like we don't have to graph that to know that's a triangle. Now, if we want to find the perimeter, what are we going to have to do first? Perimeter?
Oh, perimeter. Oh, God. The length of all sides.
We got to find the length of all the sides.
What did you say?
Now, they just gave us coordinates. How do we find the length of all the sides with a bunch of coordinates? Are you going to be able to count them spaces? Do those look like they're going to be laying on nice, even, whole numbered things? They actually may be. I don't know. But what if they're not? You're going to use a distance formula. Now, if they are laying on nice, pretty, like laying where you can count, that's fine. But if they're not, what are you going to use? Do you see why it's important for us to learn the distance formula? So if you're still struggling with that, you need to get some help. Like I posted a video you can go watch or come ask me for help or something. We got to get that down because we're going to be using it all year long. Okay? Huh? On the distance formula, I didn't record. I don't remember if I recorded one, but I posted a video. There's about 400,000 videos on the distance formula on YouTube, and I just grabbed one and posted it. That wasn't real long. It's only like 8 minutes or something. Huh? Right now? Uh-huh. I know.
It'd be so weird to be watching you just hear this voice and just like, where's it?
Hey. Yeah. Okay. But you get that, the distance formula, right? For the people who are watching this that aren't here, let's refresh their memory on what the distance formula is. Distance equals what?
Square root.
No. Square root.
Parentheses.
X minus c squared plus parentheses y minus y squared. So.
And quick reminder, 1s and 2s don't matter, right? Because it doesn't matter which order you put them in. Y'all remember that? Okay. I'm going to stop, and I'm going to let y'all start working on the practice side. I'm going to get you some graph paper. Now, listen to me. Yeah, the whole thing. Listen to me. This is not going to be homework. I'm going to let you work on it in class tomorrow. Okay? So, start it today, but then you get to work on it in class tomorrow. Okay? Let me end my video. End stream. End.